Read chapters 5 and 6 of Baby Rudin, differentiation chapter, integration chapter. Of course, differentiation was a much quicker read. Integration, as expected, was a little longer. So I'll show the book briefly and then go into my notes. Also have started reading into the next chapter, sequences and series of functions. Just to show briefly. So for differentiation, of course, and I forget if it was Wade that said it, differentiation, you're just given a rule, you run through it and you're done. In the case of integration, it's a lot more complicated. So yeah, the read for mean value theorem, continuity of derivatives. Now the proof of L'Hopital's rule, I kind of choked when I was reading this. I think what I want to do is go back and read it again. I know for a fact Bardo and Sherbert does this in gory detail, so I'm going to come back and reread this after I read it in Bardo and Sherbert. Just did not feel comfortable when I was doing it. But Taylor's theorem, very straightforward. Thanks to Wade. Wade explains the derivation of Taylor's theorem by repeatedly using MVT, the mean value theorem. That's why, of course, it's positioned that way. You just keep using it, and then you get Taylor's theorem. The differentiation of vector functions. Yeah, very straightforward. And then integration chapter. I don't know how to pronounce this name, Stieltjes. So the Riemann-Stieltjes integral, where in the case of Riemann, the little bars all have the same width, and then in the case of Riemann-Stieltjes, the distance between the bars actually becomes its own function that you can vary. Yeah, so you go from dx to d alpha of x, and d alpha of x is actually a function that determines different widths for the little bars. Then, of course, upper and lower sums, upper and lower integrals, and then the relationships between them. Right? Upper integral, lower sum, upper sum. A particularly clear part of Baby Rudin. Of course, the way the variability or whether the integration variable is a variable itself, has its own variation, it's a little terse in the proof that Rudin does, but then his mass example really drives it home. I thought this example was really, really good. I really wish that this book had more diagrams and more examples like this one. It does have many examples, but I always need more. I'm a baby. Babies need lots of examples. The back and forth between integration and differentiation, all about continuity. And then rectifiable curves, which I looked up a little as well. And that was the chapters in the book. Then I'll show the reading briefly. And of course, in this particular section of this notebook, I plan to also complete chapter 7 of Baby Rudin, even though I'm showing here only 5 and 6. I already have a few pages for chapter 7 that I'll tack on after I make this video. So yeah, this is the part of my reading that I enjoy making diagrams for Baby Rudin. Maybe they're accurate, maybe they're not, but I always try to put in a diagram for whatever Baby Rudin is saying, just because it's a book without a single diagram, which I don't like. So that was the differentiation chapter. And then in the case of integration, of course, the alpha x function. So instead of just being a constant, every delta x being the same, now you can vary the delta x. And of course, all these proofs are all about where you set up your lower and your upper. So I believe this diagram is correct for this particular proof. Yeah, I mean, when I look through it, I said, yeah, that makes sense. That does make sense. Trying to prove how, depending on where you set your bar, which area is where. And depending on where each area is how these inequalities work. Yeah, like that. All these proofs are all about how all of these bars get put together, and then the integral, the upper and lower integral between them, what those differences are. The presence of gaps, yeah, that's really what it's all about, I think. Of course, the example, and then taking it to vectors, bringing in the Cauchy-Schwarz inequality, and then rectifiable curves. And I did read a little bit about rectifiable curves, and so basically it has finite length, it has a Lipschitz continuous parametrization, has a linkage to complex analysis, of course. When I did Safran-Snyder, and you can see that in my channel when I read that part of Safran-Snyder, the parametrizations all have the same length, but they have a different function. And they're either arcs or complete curves that kind of become a complete cycle. Yep, so I read a little more about that. And that was chapters 5 and 6 of Baby Rudin.